The universe is a mysterious place. Stars shine for billions of years. Galaxies dance across the cosmos, and planets orbit distant suns. But among all these celestial bodies, there are places where the laws of physics seem to break. Places so extreme that nothing can escape them, not even light. These are called black holes. But what exactly is a black hole? Let's simplify it. Imagine a massive star. Throughout its life, it balances two forces: the outward pressure of nuclear fusion and the inward pull of gravity. This balance keeps the star stable. But one day, the star runs out of fuel. When that happens, fusion stops and gravity wins. The star collapses on itself with unimaginable force, forming a black hole. This collapse is so intense that all the star's mass is compressed into a single point called a singularity. Surrounding this point is an invisible boundary called the event horizon. Anything that crosses this limit is lost forever. Not even light can escape. But if nothing can escape a black hole, how do we know they exist? If black holes don't emit light, how can we detect them? The answer lies in the effects they have on their surroundings. Even though they are invisible, black holes influence space in ways we can observe. One of the most common ways to detect a black hole is by observing the movement of nearby stars. If a star is orbiting something invisible at extreme speeds, that could be a sign of a black hole's presence. Another way is through light. When a black hole feeds on surrounding matter, this matter forms a spinning disk called an accretion disk. This disk gets so hot that it emits intense radiation, often visible as X-rays. Then, in 2019, we achieved one of modern science's greatest milestones: the first direct image of a black hole. Using the Event Horizon Telescope, scientists captured the silhouette of a supermassive black hole at the center of the M87 galaxy, a dark circle surrounded by a glowing ring of superheated matter. This was definitive proof that black holes truly exist. But if observing black holes is already difficult, understanding what happens inside them is an even bigger challenge. Now we get to the question everyone wants to ask. What would happen if someone fell into a black hole? Well, first of all, it would be a terrible idea. But since we're just imagining, let's go with it. As you get closer to a black hole, the first thing you'd notice is gravity getting stronger and stronger. If you were falling feet first, your feet will be pulled much more forcefully than your head. This effect has a funny name: spaghettification. Yes, you'd be stretched into a long, thin strand, like a piece of spaghetti, until you were completely torn apart. Not a pleasant experience, right? But what if somehow you survived and managed to cross the event horizon? What would you find on the other side? The truth is, no one knows. The laws of physics, as we understand them, stop making sense inside a black hole. Some theories suggest that everything is crushed into the singularity, an infinitely dense point where time and space collapse. Others propose more fascinating possibilities: wormholes, alternate realities, or even entire new universes. But don't worry, the nearest black hole is thousands of light years away. Unless you're planning an irreversible cosmic journey, you're perfectly safe here. Still, there's one last question we need to answer. Do black holes live forever? So far, black holes seem like unstoppable entities, devouring everything around them and trapping even light. But do they last forever? At first, we might think so. After all, if nothing can escape a black hole, how could it possibly disappear? But this is where physics surprises us again. The famous physicist Stephen Hawking proposed a groundbreaking idea: black holes can slowly evaporate. This happens through a phenomenon called Hawking radiation. According to this theory, space isn't truly empty. Tiny virtual particles constantly appear and vanish. Near the event horizon, some of these particles might escape, stealing away a tiny bit of the black hole's energy. Over time, a very long time, it would lose so much energy that it would simply cease to exist. But how long would that take? For supermassive black holes, it would take trillions upon trillions of years. In other words, they'll be here long after everything else is gone. But this raises another question. What happens when the last black hole evaporates? If the universe keeps expanding and cooling one day in an unimaginably distant future, there may be no more stars shining, no planets orbiting, no black holes consuming matter, just an endless, dark, and silent void. a true end of time. But that's just one theory. The universe still holds countless secrets, and black holes are just one piece of this enormous cosmic puzzle. Who knows what else we'll discover? And speaking of discoveries, if you could travel inside a black hole and see what's on the other side, would you take the risk? Well, we've reached the end, or have we? If black holes have taught us anything, it's that not everything that crosses the event horizon is lost forever. So, why not leave a sign that you were here? If this video expanded your mind, or at least didn't crush it into a singularity, leave a like. It helps this content travel through the vast universe of YouTube. And since we're talking about things you can't escape, you can try, but sooner or later, you'll end up subscribing to the channel. After all, knowledge has its own gravitational pull, and once you enter this world, there's no turning back. Oh, and let me know in the comments, if you could step into a black hole, what do you think you'd find on the other side? Let's see how far our imagination can take us. See you in the next video. That is, if we're still in the same space-time.